We physicists have held up 100 years beginning around 1916 for this photograph. It is a region where dim openings might just be perhaps of the most charming and clandestine idiosyncrasy known to man. They are tremendous beasts to the extent that power, but essentially impalpable to us. A dim opening measuring might be 2 to multiple times the mass of the sun might be one of these because of the assessment offered over the course of the past years. We have gone from knowing in a don't real sense anything about them to figuring out progressively more extremely close and individual, remembering that things have absolutely gotten more crazy. Kaku has pronounced that we finally got to actually take a look at what has returned to front a dull opening. This new information reveals insight into nuances the universe of science might have missed from the beginning. Oblige us as we dive further into dim openings and unveil what's inside. Space is enormous. Anyway, what are dim openings? Before we plunge into the nuances of what Kaku draw back down, we want to analyze the stray pieces, but the majority of us have some considered what dim openings are. There are still openings in our getting a handle on. In 1916, Albert Einstein distributed his speculation of general relativity, which expected the presence of dim openings around. Then the thought was totally speculative. It required an additional 50 years for laid out specialists to find proof of their existence, which happened during the 1960s. Experts analyzing the Cygnus gathering of stars saw an oddly brilliant blue star releasing X-bars. The star wasn't lifeless, it was surrounding a Goliath dim item. Upon extra assessment, it was seen that the X-pillars were being sucked into this thing, thus the term dim opening was sired. This revelation was basic, since it exhibited that dim openings were a deception of Einstein's imaginative brain, as well as a certified substance in space that we genuinely expected to learn about. Researchers, sir, the world started to focus on this dim opening named Cygnus X1, arranged in the Cygnus eminent body around 6,000 light, a very long time from Earth. It was on various occasions more splendid than the sun, and incredibly thick with such a strong gravitational draw that not even light could escape from it. Consequently, it is known as a dim opening. The possibility of a dim opening is both fascinating and terrifying. A neighborhood of room where gravity is strong to the point that nothing, not even light, can whatever gets unreasonably close to a dim opening will not be moved into it, ever to be seen again. This risk makes it impressively more basic to learn all that there is to be know about them. Later, finding Cygnus X1, scientists started searching for other dim openings and found there may be almost in excess of 100 million dim openings in the smooth manner alone. Considering the way that they are so unfathomably hard to distinguish, we actually don't have an exact number. By the by, it appears there are a couple million dim openings in our very universe, making them fundamentally more crucial to focus on. The chief concern with dim openings is by and large gravity. Their gravitational power is uncommon, so much that anything entering it packs down vastly until it transforms into a current. In less complicated terms, dim openings look like limitless vacuum wells that suck everything in. Potentially of the most frightening piece of dim opening investigation is that, assuming someone some way or another figured out how to fall into one, they would be reached out into a single line. This connection would happen bit by bit, and the individual would kick the container before the last design sets in. So could we just say no one should step into one in any case, since they are all over? Could we sooner or later genuinely be in danger? Despite the closest dim opening being 500 light years away, it is still sufficiently close to raise issues and worries. In 2021, exploration had the choice to convey the primary clear photograph of a dim opening, explicitly the M87 dim opening. This dim opening was caught more than a few nights in progression, and with every photograph the researchers collected more proof. They expected to secure the singular photos together to make a total picture, uncovering that there are 3 layers to a dim opening. It's not just one single growing opening of nothingness, as numerous people acknowledge. The cycle incorporates persevering through the underlying 2 layers. Preceding showing up at the nothingness part, the main layer is known as the occasion skyline. When you pass this point, there is no pivoting, you will be sucked into the dim opening. The resulting layer is the photon circle, where light circles the dim opening. Any light entering this locale will be gotten and unfit to move away from the dim opening's gravitational draw. Finally, we come to the 3rd layer, the peculiarity. This is where all that enters the dim opening gets stuffed until it transforms into a peculiarity, a point in spacetime where the laws of physical science as we presumably know them discrete, and we can't predict what happens next. The thickness at the peculiarity is unlimited, and the laws of physical science quit existing. What makes this immeasurably more horrendous is all that each and every dim opening concentrated on will be out and out, not exactly equivalent to the last. They will frequently follow a comparative 3-layer thought at this point, how they capability can be endlessly unique. Regularly concentrating on such singularities would remember returning for telescopes and seeing comprehensively. Yet with dim openings this isn't conceivable. Specialists can focus on dim openings by suggestion, by seeing the radiation they emanate and the gas and residue enveloping them. Sending a test like Explorer into a dim opening is incomprehensible, since anything that enters the occasion skyline is pulled towards the peculiarity, where it is compacted to a vastly little Point is needs be we can't waste billions of dollars on tests that would just be crushed into nothingness. Scientists are left with no choice aside from to focus on these things in a two-layered manner in spite of the way that they are three-layered characteristics to make matters essentially seriously testing every dim opening is remarkable and the laws of physical science separate while examining inside the suggests standard procedures for coherent solicitation don't really apply to dim opening contribute examinations. Anyway, researchers haven't been dormant. There are a seriously huge number of theories and explanations about dim openings. One persuading theory is that they are produced using falling stars. Exactly when a star drains generally its fuel, it can at absolutely no point in the future produce adequate energy to adjust gravity, making it break down in on itself and potentially transform into a peculiarity. To grasp the idea of dim openings, start to finish, NASA analysts coordinated their fixation toward the focal point of the system and 87 cosmologists saw serious areas of strength for an exceptionally warm hydrogen gas turning at a stunning speed of 1.2 million miles per hour. The sheer force of the turning plate of gas should have made it fly separated at this point. It didn't. Analysts contemplated that a legendary mass assembled at the focal point of the system held this back from happening. This immense item, gauging however much 2 to 3 billion suns, could simply be a dim opening anyway. That isn't the main speculation. In 1963, New Zealand mathematician Roy Kerr used Einstein's circumstances to portray a transforming dim opening, proposing that it wouldn't collapse into a point yet, perhaps structure a ring of shoot or a slight circle. This turning plate of issue, called the ergosphere, is the region, including the dim opening, where the laws of physical science start to isolate. Core condition also expected the presence of an Einstein-Rosen extension or wormhole, a theoretical section through spacetime that partners two separate areas of the universe, or to be sure, even two equal universes, excepting one were to fall into a dim opening. As opposed to being crushed, they might be sucked down an entry through the ring of discharge and shot out of a white opening in an equivalent universe. To sort out how this capabilities, consider the idea of spacetime in Einstein's theory. Presence is interconnected, framing a four-layered surface called spacetime. Objects with mass contort this message, making a gravitational field that makes various items move towards them. Imagine a piece of paper tending to spacetime. If you put two spotlights on the paper and characterize a limit between them, it addresses how items travel through spacetime. On the off chance that you could fold the paper in half to make a shortcut between the two centers, this represents a wormhole, a simple route through spacetime that connects two distant points instantly. Wormholes aren't just a sci-fi concept. They are a prediction of general relativity, though no one has seen one directly. Wormholes are inherently unstable and would collapse rapidly. The existence of an Einstein-Rosen bridge would imply that black holes are not merely grandiose vacuum cleaners, but could also serve as gateways to other regions of spacetime. Could we eventually use a wormhole to travel through reality? Unfortunately, the answer is likely no, not yet. Even if we could stabilize a wormhole, it is unlikely we could use it to travel faster than light. Einstein's theory of special relativity predicts that the speed of light is an absolute limit on how fast anything can move through spacetime. Despite this, the concept of wormholes and black holes as pathways to other parts of the universe, or even different times, has fascinated physicists for a long time. The idea of shortcuts through spacetime that allow for crossing vast distances or even traveling into the past could be revolutionary if feasible. The Kerr wormhole, named after Roy Kerr, is one of the most intriguing concepts in this field. A theoretical passage through spacetime could connect two otherwise distant points, like different universes or various times within the same universe. The Kerr wormhole is ring-shaped, like the mirror in Alice in Wonderland, where passing through it could potentially transport a traveler to another universe or time with different physical laws. While the possibility of wormholes as methods for interstellar or time travel is exciting, it is also controversial. Some physicists argue that wormholes, particularly Kerr wormholes, may be unstable or challenging to traverse due to intense radiation and subatomic forces. Physicists point out that Einstein's equations, which describe wormholes and black holes, only apply to gravity and not to the quantum forces that govern radiation and subatomic particles. To fully understand these phenomena, a new theory is needed that unites gravity with quantum theory. A theory of everything that merges Einstein's theory of gravity with quantum theory. Michio Kaku, a renowned theoretical physicist, has been working on a theory of everything for decades. The most promising candidate is superstring theory, which unifies gravity with quantum theory. It proposes that subatomic particles are tiny vibrating strings and that the universe is a symphony of these strings. Just as different musical notes correspond to different vibrations of a violin string, different particles in nature correspond to various vibrations of a superstring. Superstring theory also explains several peculiar phenomena by showing that, as strings move through time, they curve the fabric of space, creating black holes, wormholes, and other exotic solutions to Einstein's equations. However, the extra dimensions of spacetime required by superstring theory are so small that we cannot observe them directly. The most precise measurements in our laboratories only use the 4 dimensions of spacetime we are familiar with: length, width, depth, and time. How can we be sure the extra dimensions exist? One possibility is that these dimensions are curled up so tightly that they are invisible to us, like a sheet of paper tightly rolled into a cylinder. If you were an ant walking on the paper, you wouldn't notice the curve. Similarly, the extra dimensions of spacetime in superstring theory might be compactified into tiny loops or spirals that are imperceptible but influence the behavior of the strings vibrating in them. Another possibility is that these extra dimensions were more visible at the beginning of the universe, during the Big Bang. According to some versions of superstring theory, the universe began in a state of 10-dimensional spacetime, with all dimensions equally apparent. As the universe expanded and cooled, the extra dimensions began to fold and compact, leaving us with the 4 dimensions we observe today. If this is correct, we may be able to detect traces of the extra dimensions around us. The science associated with superstring theory is extremely complex and has opened new areas of mathematics. However, solving the problem of a quantum black hole has proven challenging. While many physicists have tried, no one has yet succeeded. Edward Witten, from the Institute for Advanced Study at Princeton, has called superstring theory 21st century physics that fell accidentally into the 20th century. Last year, some physicists announced a significant breakthrough. String theory might completely solve the problem of a quantum black hole, but in 2 dimensions, not 10. Many believe it's only a matter of time before someone cracks this problem. Until that point, it's still too early to expect intergalactic or time travel attempts. With this, one thing is clear: there are just too many questions and even more potential answers. Michio Kaku's string theory adds a new twist. Perhaps the Big Bang wasn't as big as we usually think. It wasn't a massive explosion or a chaotic blast, as one might imagine. The theory of the primordial cosmic explosion doesn't explain what caused the supposed bang or how it happened. It just states that it happened. We truly need a theory that explains what occurred before the Big Bang. String theory suggests that our universe might have formed from the collision of 2 separate universes or emerged from another universe, like a child being born from its mother. This connection between universes is known as a wormhole, comparable to a tunnel linking 2 bubbles. We may have just found evidence of this umbilical cord linking our universe to another. In a way, we could be living inside a black hole without realizing it, as we exist in 4 dimensions and cannot see beyond them. It's possible we are inside a black hole, and the black holes we study are wormholes to other dimensions.